educational moment. All right, so we're coming to the very first part. This is a little tricky. Oh, thanks. There we go. Turn down the lights. It'll come up. It takes a moment. If you go back, the very first command you have to do there, let's zoom in, is a bit of a challenge. I know, this is deliberately a challenge here. So, we're constructing kind of a complex statement here to create a new table of just protein coding genes. Is this still legible? We may have to figure out how to do this in the future with that. We'll try this. All right, so there are three parts to this statement that you have to construct. One is you need a new variable. This is going to be your new data frame called PC genes. It'll just hold the protein coding genes. So to create this new data frame, you have to give it another data frame. So we're taking this data frame and we're assigning it to that one. But actually, in here now, we're only going to specify a subset of that data frame. And the way you specify the subset is with this indexing notation. There's actually, you can use Boolean commands like this. So you can use equals to. So anything in this column called gene type, where the value equals protein coding, then that's going to be the row in here that's assigned to PC genes. It's a little confusing perhaps here, but here's how the statement works. PC genes goes on the left. There's your new data frame. You're assigning this other data frame, or a portion from this other data frame, to this new data frame. And now, within these brackets, you're telling it what portion of the data frame to assign. So that's the solution to that problem here. Now, something that's critical to note is these brackets are not the same thing, obviously, as parentheses, and they serve different functions in the program. It's critical that you know the difference. So the brackets are used for indexing, as we've done over here. You can put for identifying subsets of data frames. As you saw in the homework before, brackets can encompass a list of multiple values, a list of data. Bracket basically identifies parts of a list, whereas a parentheses encloses arguments to a function. So, like when we calculate the mean down here, for square distances, if there's some sort of function, like this is the append function, and here's another here's the append function, and so what goes inside of it is enclosed in parentheses. And then the final use for parentheses is just straightforward math, the way you use parentheses in math, right? You do this subtraction first and then that. All right. Any questions about this command here before I sort of explain one last? Ask for help. Send me an email. Come to the tutorial session if this doesn't quite make sense. Finally, so we wrote a for loop, if you got that far in this, we wrote a for loop. There was one problem here where I said I entered this command, I tried to use indexing notation, and it seemed weird. It wasn't giving me the answer. Well, here I used indexing notation wrong. So what you want to do is you're passing a part of this data frame, PC genes, to this function, mean. This is what the dot notation here means. Here's your data frame, and mean's going to operate on that. So actually what has to happen is I only want it to operate on a portion of the data frame. So here you completely specify your data frame. I'll get rid of these parentheses here. Now the command should work. So you tell it what's going into the function, and then you have the mean. And actually this is maybe a little non-intuitive because you're not putting an argument in here. It's just going to take the mean over that entire column. So there's your shortcut. All right, I know we're at the end. We're running out of time here. Any questions on what we did so far? All right, please come for help. We'll in the tutorial session Thursday at 5:30.
So before people
Yeah.
leave, can I just, this is the first time we've run this course. So how many of you had previously downloaded any genomic data, like text files before today? Some of you I assume did. Please, if you have done it, raise your hand high so I can see it. Okay, so some. And then how many of you had manipulated it in, this wasn't that complicated, to me it's complicated. How many of you had manipulated some genomic data? I assume it's the same, or have you just downloaded it? So if you had manipulated it in some way? Okay, so for most of you, downloading the data from the database was basically an infinite jump in knowledge. It was for me, I hadn't done it. And then manipulating it in some way. I didn't get to the for loop stuff. When he was explaining the for loops, I finally had figured out how to calculate the damn two-prime So, and to me, it's still, clearly I don't know how to do a lot of this stuff. The question is, how many of you understand exactly what you're doing and why? And my guess is the answer is probably, unless you knew how to do this before, most of you don't quite get it, because I don't quite get it yet. And I think what you can do now, though, is you can go, you have your data table, and it's going to take practice, because it's a new language. In order to figure out how to understand a new language, you have to practice. So you can go and manipulate it in different ways relatively easily. I think you can all figure out how to do that intuitively, and it just takes practice, and I'm assuming and telling myself this, to figure it out. So avail yourselves of the tutorial sessions, Thursday 5:30 to 6:30. If you think it would be helpful to have another one on Monday, send me an email. We can see if we can do that. I can't promise anything. That is not a license to wait to do the damn homework until Monday. But I get it that Thursday might be a little too early, but some of you will go, just bug me. Anyway, thank you.
Yep. Before you close out, if you didn't make it that far, just enter this command so you can actually save your new table to file.